What's up everybody, the Networkberg here. Hope you've been doing well. In this video we will be tackling IPv6 in a in a live lab using EVNG to go through the setup of IPv6, kind of like what it is, and we will be also just adding it on stuff like BGP and OSPF. So it's going to be an interesting and fun video because it's something that even I myself don't actively work with, is IPv6. So I figured it'd be cool if we just created a lab and helped each other out and see what the heck is going on. So anyways, without further ado, let's get into the video. Alright, so let's start building a topology in EVNG so that we can play around with IPv6. So I'm just going to add 4 MikroTik routers. I'll leave their name on MikroTik. I'm not going to use version 7, even though it's really cool, the stuff that they've been doing on version 7. This is all beta and there's a lot of features that's not working on it at all. So we'll use version 6.4.7.1, it's an image that I have already. And we'll add 12 Ethernet ports, because I kind of just like having 12 ports on the routers because it makes them feel like they are maybe a CCR that you're working on. Alright, so let's move our routers around. And I might just add a management bridge so that I can just access all these MikroTiks directly on Winbox without having to set up ROM and that stuff. Oh, and this will give the router some breakout, but that's only through my IPv4. Because this is something I want to stress with people, because I see a lot of people thinking you can build an IPv6 network on MikroTik and then you can NAT your traffic out as IPv4. And on MikroTik that does not work. That doesn't happen because MikroTik doesn't currently support NAT64, which is a, let's say, a mechanism that allows you to NAT IPv6 addresses to IPv4 and vice versa. You can NAT IPv4 addresses to IPv6. MikroTik doesn't have that. So if you want to do that, you're probably going to have to deploy additional infrastructure, maybe a different router that can do NAT64 so that you can NAT the traffic in and out through that router. But if you're just going to start spanning an internal network with IPv6 and you want to get to the internet using your IPv4 addresses as currently on your infrastructure, it's not going to work unless you get something that can do NAT64. Okay. So we've got our 4 MikroTiks. I'm just going to start them up. And I do really actually like IPv6. It is interesting because it kind of breaks your head a little bit as well, because it's not this plain normal thing that you work with on a day-to-day basis. Alright, let's see. I've got my 4 MikroTik routers. I can see all 4 of them. So that's router 1, router 2, router 3, router 4. Alright, so let's just Winbox onto router 1 quickly and see what's happening there. So first things first, if you want to run IPv6, you need to enable it on your router. So if I go into my IP here, you'll see there's nothing. There's nothing going on here. There's nothing about IPv6. If I go into my addresses, I can't assign IPv6 addresses here. It doesn't work. It doesn't allow me to do that. So I can't do this. But if I enable IPv6 on the router, I can actually start adding IPv6 addresses. So to do that, we simply need to go into our system, packages, and then your IPv6, it will be there. It's just going to be in a disabled state. So we can just enable that. And then it's scheduled for enable. So all I need to do is quickly reboot the router. So system reboot, yes. And I'll quickly do the same for all the other MikroTik routers. So I'll just quickly do this on the command line because it's fairly quick to do. So system package print system package enable 3. And that's going to be the same on all of my other routers. I just printed here to make sure. I would strongly suggest, if you do it via the CLI and you're using a physical router, just maybe check as well, because you might have additional packages installed and it might not be number 3 for you. Okay. I'm being silly now because I haven't rebooted those routers, so I need to log back into them anyways. System reboot. Yes. Okay, so let's just get back on the other routers, reboot them as well. System reboot. Yes. It's going to reboot. And then the last one. System reboot. Yes. And there we go. All 4 of our routers will now reboot, and they will have the IPv6 package installed. So let me go back onto router 1. There it is. I'm connecting back onto it. Let me just close all the windows. And then very simple, you'll see now there's an IPv6 option here. So that is what I want to get you to focus your eyes on, because a lot of people miss this. And then they're like, where the heck do I add IPv6 addresses now? So you'll just go into this IPv6 address space, and then you can go into your addresses, and just like your IPv4, if I go here, it's an address list, but it's just for your IPv6 addresses. So by default, when you start this up, each of your interfaces will get their own unique link local address. So it's this address that starts with the FE80, and this will allow this entire network to basically be able to broadcast over this address space. So each interface will have its own IPv6 address whenever you bring it up. Simple as that. If we want to add a new IPv6 address, all that we need to do is click on this plus, and then we can specify our own IPv6 address. So I'm going to leave this as a /64 because it's the easiest for beginners like myself even to understand what the heck is happening with IPv6. Because with IPv4 we only have 32 bits. In IPv6, how many do we have? Not 64, we have 128. But if we just use /64, you can almost think it's like double the amount of IPs and stuff. But don't get confused. Another thing with IPv6 is you get hextets, which is basically like 8 spaces where you can fill in hexadecimal values. And then with IPv4, you've only got the 4 octets where you can put in IP informations, which runs from 0 to 9. So let's quickly add a IPv6 address. So I'm going to assign myself a global address. So let's make it something like 2001 colon. So if you're not aware, with IPv6, the first hextet gets assigned to you by IANA, which is the, think of it as the big number association, which says, yes, you can use these numbers or not. The second spot, that is going to be allocated to the registry, which is maybe going to be RIPE or Afrinic or ARIN or those type of places which allocates ASNs and network spaces to ISPs and such. So they will get their own little code that they would put in here. So let me just maybe make that 2000. And then finally there's a space that the registry will give to the ISP. So maybe that is like 3000. And then the ISPs will give you as a company your own little block. So it might be like 1000 or 2000 or whatever they feel like. But remember, these are all hex values. You can, it's from 0 to 9, and I think A to F, you can assign different type of values in there. So you see, that's the difference. We could shorten this as well, but not this address, because any zeros that is on the left hand side in a hextet you can basically shorten, but not if there's a number or something before it. So maybe if this was 0020, we could have written it like that or something. And then at the end, I'm just going to assign the address .1, because that will be the IP address of this interface I'm going to add it on. So let me add that IP actually on, we can add it on Ether1 as well. That won't be an issue, because Ether1 is also connecting to that bridge of mine on the lab. And here we can set some different values as well. So we can do EUI64 or NoDAD, which is basically like a DHCP, but it's not DHCP, where addresses check if they share the same address or not. And this advertiser is very interesting, because this actually lets your neighbors know what your address is and if you're using IPv6 as well. So let's apply this address to Ether1. And then you see it has this G here for the global address. And that is now on Ether1, and that is being advertised. So next step, we need to put this on another router so we can actually see if the IPv6 is working. So let's connect on Winbox again and go into MikroTik 2, which is this one. And we'll connect to it. Close all the windows and go into our IPv6, go into our addresses. Let's add a new address. And our other address, I believe, was 2001 0. Let's make that 20. Did I make it 3000? 1000? I'll confirm the numbers just now. /64, and let's make that 2. Okay. Let me just go back onto router 1 so we can see what IP we made there. I could have actually just copied this, but I think I am right. Okay, and .2. So I'm going to put that on Ether1 as well, and I'm going to apply. So the address is red because it's just checking if there is another address that has that IP. If there is no IP, then it will just accept that that's the correct IP, and that's an IPv6 address, and it is live now. So how can we test? Well, we can actually do a few things. We can have a look at our IPv6 and we can look at neighbors. And this should bring up a neighbor if there is any neighbors that's connected on the network, but I don't see any. And the other thing we could do is just probably run a ping. So let's do a ping 2001, 20, 3000, 1000.1. And I am getting a reply from that. So I am able to ping that IPv6 address. It looks a bit weird because it says echo reply, and usually if you work with let's say IPv4, if I just do like a ping to 8.8.8, you just get this. It just gives you the milliseconds and stuff. It doesn't tell you the status echo reply. So it looks a bit weird, but that's normal. That is normal. Okay, cool. So we've actually assigned some IP addresses, and there we can see the neighbors as well. Okay, so let's quickly just assign some more IP addresses on the network so that all 4 of these routers have addresses on IPv6. I might just quickly do this on the command line as well, just to show you how we can do that. Ooh, I've seen this happen. So for whatever reason, my emulator doesn't like when I put on the IPv6 and I just restart the router. I first need to restart the whole lab before it works. So I can just do this on Winbox as well, but I'll just do it through the Winbox command line because that isn't affected. So let's connect. And we'll go into IPv6. Actually, no, just our terminal. See, there's our good old terminal. It works. It would have just been like a PuTTY session. All right, so IPv6 address, add, and then we can put in an address, because you see instead of using IP address, I'm using IPv6 address to add a new address. I can make this .3, and then my interface will be Ether1. That's it. I've added IPv4 address now on router 3. So let's do router 4 and then we are done. Connect. So IPv6 address, add address equals, think of that as .4, and my interface is Ether1. Cool. Cool. So let's look at our neighbors again. IPv6 neighbors. Let's try to do some pings. But I also think it's because my links aren't directly connected and I'm just pinging to see if the address resolves. I might just up arrow this and take this address and just type ping. And let's ping .3. Oh, I need to just remove that. There we go. So .3 is responding. .2 is responding. .1 is responding. All right, grand. So we have IPv6 connectivity between all 4 of our routers. Let's go into the next cool thing. Okay. So again, fairly important, IPv6 on MikroTik is its own thing. So whatever you see here in IP, this is only for IPv4. So even your firewall, your DHCP server, all this stuff here, this is only for your IPv4. The only things you can do on IPv6, you need to go to your IPv6 tab for. So we can add the addresses, we can have our own IPv6 DHCP server, we can have our own IPv6 firewall. Very important, because this firewall rules, mangle rules, these connections, this only relates to IPv6. This will have nothing to do with your IPv4 connections. So a mangle rule that you put here will not impact anything that's running IPv4. Your filter rules, same thing. So think of this as two separate networks, an IPv4 stack and an IPv6 stack. And these stacks, they're not directly able to communicate with each other. It would have been nice, and NAT64 kind of lets you do that, but in this case, you're building an IPv6 network and it will connect as IPv6. Okay, so besides in this IPv6 section, there are other places where some additional IPv6 options become available, and that is actually prevalent in your routing. Now, if you go to your routing, what do we see there? That's a shocker. Suddenly we get here OSPFv3. What the heck is that? So OSPFv3 is OSPF, but it was made specifically for IPv6. Now, if we go into our OSPFv3, let me just close all the other windows and go back in there, OSPFv3. You might notice there is a little bit of a change or a difference if we want to compare the boxes. So let's just open up the plain OSPF box as well. So the biggest difference that I can already see when I have a quick look here or a glance is, where the heck is my networks? I don't specify any networks on OSPFv3. Okay, that feels a bit weird, but that is how it is. So basically you're just going to set up your instance and you'll have your area still, but you're just going to do everything using your interfaces. So with your instances, you can redistribute whatever routes, but your interfaces will allow the OSPF to form relationships with neighbors, and then they can learn routes through with each other. So let's quickly configure OSPF on this network so that we can at least learn and redistribute some routes and stuff. So I'm just going to double click on this default one. I like to just call this my backbone router ID. So this is router 4, so I'll make this router ID 4.4.4.4, and that's all that I need to do there actually. Next bit I want to do is go into my bridge, because I just want to add a loopback address, because this is also pretty standard if you're running a routing protocol, is just to, because if we go into the OSPF, this router ID, this is 32-bit, so this doesn't change ever. But don't think of the router ID as an IP address. This is just an identifier. So I'm going to add an IP address called 4.4.4.4 on allo 0. I actually don't need to do this, but sorry, it's an old habit and it dies pretty hard. Okay, so let's add our interfaces. So this is actually the important bit. So you could just put this on all and it will throw it on all interfaces, but I already know all my routers connect on Ether 1. So I'll select Ether 1. My area will be backbone, and your network type. Usually this used to be on broadcast. And with IPv6, broadcast is not a thing anymore. So broadcast networks are dead. The only things that you're doing with IPv6 is unicast, multicast, and the new cool kid anycast, which is basically where you can assign the same IP address to multiple devices, but the closest device would be the one that's preferred for connectivity. So you might see this with stuff like Google's DNS server 8.8.8.8. Most of the countries have some local 8.8.8.8 server that they connect to, and that's basically like what anycast is doing. You're connecting to that local 8.8.8.8 server instead of the one that's sitting in Europe or the US or something. But broadcast, you're never going to use this. Ignore that. You could probably leave this on default. I tend to just make this point to multi-point or point to point, but I'll make this point to multi-point because those are 4 routers, and I'll just enable BFD because it's a nice protocol. So let's apply that, and then I need to do the same on all of my other routers. So I'm actually not going to add the loopback address on the other routers. So here's router 3. Let's quickly go into our routing, OSPFv3 instance, call this backbone 3.3.3.3, apply interfaces. We can select Ether1, use BFD, and make it point to multi-point, apply. So I should actually see a neighbor already, and there we go, we do see a neighbor. And if I look at my neighbors, I can see router ID 404.4.4, and there is the address, which is the linked local address on Ether1 actually, and how many state changes. Here you can see your LSAs, what route you're learning and not learning and all that stuff. And OSPFv3 routers. Okay, cool. So let's quickly jump back into the other routers, router 1 and router 2. Just enable OSPFv3 on them as well. And sorry, I don't want to make it seem like it's a boring lesson, but I want you to see how the network as IPv6 comes online, so that you don't just get snips and parts of it, because I find it quite lacking in knowledge if you need to like only look at little parts of snips and see how this stuff is set up, and that you don't get the bigger picture, because the network is a bigger picture. It's not just clicking one setting. All right, let's go into our interfaces, backbone, Ether1, use BFD, PTMP, apply. 2 neighbors. And now for the last one. So routing OSPFv3, call you backbone, call you 2.2.2.2, apply. Let's add our interfaces, Ether1, PTMP, apply. So now I should have 3 neighbors. Cool. So I've got relationships with all of my other routers, and I can actually start learning routes and such. So on router 1, let's go back onto router 1. Let's advertise a IPv6 route via OSPF quickly. So on router 1, as you see, there's no networks tab here, so we can't broadcast it through there because there is no broadcasting. But what we can do is maybe just set up another bridge. Let's call this LO1, or LO1 is good. And let's go into our IPv6, go into our addresses, make a new address, and let's make this address. Oh, by the way, if you want to add a loopback address, you can just do something like that. Like, I think that's acceptable for a loopback address, or that, or that, or that. But let's advertise a range similarly to the one that is connected on our WAN or on our interfaces. So let's make this something like 2002, 30, 3000, 1000, and let's make that also .1/64. I'll assign this to my LO1. And I'll apply that. So that's just a IPv6 address that we've assigned to a broadcast, or not a loopback interface, and we're going to now redistribute this route via the OSPF. So to do that, let's go back into our instances, double click it, and now we can just say redistribute connected routes as type 1, because that is the type of route it would be. Apply that. And if I now go to my other routers, so let's go to router 2, and I go into my IPv6 and I go into routes, I am learning this 2002, 30, 3000, 1000/64 route through this interface, through this IPv6 address. So I am learning it through OSPF, and it is working. So if I was going to do something like ping 2002, 30, 3000, 1000.1, I can ping it and I can get a response. So now we have set up OSPF on an IPv6 network. Okay, now the real cool stuff. So let's do a little bit of BGP, because that is something that I love, and a lot of people like BGP because it's the the protocol of the internet. So let's go into our routing. Let's do something between router 1 and router 4 perhaps. Okay, that should be fine. So from router 1, I'm going to go into my routing. The nice thing about BGP is it works with IPv6 out of the box. So you still need the package enable, but you see there's no like BGP v2 or something that you need to work with. It's still the same config that you're using. So we're going to set up an instance. So I might create a new instance, call this AS100, make the AS100, and the router ID is 1.1.1.1, and I can just apply this, and let's add a peer. So our peer, what we're going to do is, let's look at our peers, let's give it a name. So I'm just going to call this peer to AS, maybe 103. I'm going to use AS100 as my instance, and my remote address, this will now become my IPv6 address of router 4. So let's go quickly fish that out. Let me go into my IP addresses, router 4, copy that. Now I'm being silly. Going to IPv6, there is our IPv6 address for router 4. So that's the remote address, remote AS 103. I'm not going to put any filters in, but that is a pretty good thing to do if we're going to peer. And let's maybe advertise a default route to router 4. I'm going to apply that, but it's not going to work yet. And I know why, but we'll fix that up after we've established the peers. So we need to jump back to router 4. So on router 4, we can go into our routing, BGP, add a new instance, call it AS103, AS103, apply. I'm going to go into my peers, add my peer. So let's call this peer to AS100. My instance is AS103, and my remote address is going to be the IPv6 address of router 1. My remote AS is 100. Everything else I'll leave pretty default. I'm not going to send them a default route. And let us apply. So our peer should actually establish, and it has established, and I am getting a prefix. I am getting a route. Let's go into our routing and IPv6 actually and look at those routes. So those are the routes that I'm getting, but I'm not seeing this prefix, even though it's telling me there is a prefix. And there's other routes that I actually want to redistribute as well, or send out to the network, but I'm not getting them. So let's quickly jump back to router 1, and on router 1 we first just want to set something up. So go back into our peer, and what I want you to take note of is in your peer, when you go to your advanced tab, your address families, that's pretty important. So address families relate to what type of protocols and stuff can be running over this BGP peer. And at the moment it's just set for IP, which is IPv4. So I need to actually enable IPv6 as well. And I can just apply that. So let's apply that on both routers and see if there's a difference. So I've applied that on both routers. The peer is going to reestablish, and now I'm getting actually the prefix that I'm expecting. Let's go into our IPv6 routes. Now I'm learning a default route through that interface via BGP. So we can see we are receiving it from there. It is a unicast. It is a default route on IPv6. That's what the IPv6 default route looks like. And here we can see our BGP details. Cool, so that is working. So I actually want to now set up a loopback address on router 4, which I've already done. So, but let's create another loopback address. Call it loopback1, LO1. And let's add another IPv6 address. Let's maybe make this 3000. And I'm not going to fill the other stuff in. Let's just make this 3000 and put that on LO1. Going to apply that. Actually, let's extend that so people can see, have a better look. So 4000, 5000, 6000, and these two colons just basically means they're a bunch of zeros. So let's apply that, and now we've got this address. So let's actually advertise that route via BGP, and it is the same process as on your IPv4 again. So go into your BGP, we'll go into our networks, and then we'll just advertise this new network, which is 3000, 4000, 5000, 6000, 0. No, we don't need to do 00 / 64. We can apply that. And now router 4 will be sending this BGP route to router 1. So if I go into my IPv6, I go to routes. There is the route that I'm learning via BGP from router 4 on router 1. So now I am also building and learning routes through IPv6 using BGP on MikroTik. I actually think this is where I want to conclude the lesson, because IPv6, again, it's something a lot of people don't work on a daily basis, and it is also something that is coming quite strong because we are running out of IPv4 addresses. We need to get ready with this stuff. So please, I implore you to actually learn. I'll put a link in the description of a video that I watched quite recently that helped me just understand IPv6 again a bit more fundamentally better, so that I am prepared for when I need to look at transitioning from an IPv4 to IPv6 network. Some cool stuff with router version 7, because this is actually something that sucks for me with IPv6 in the current version. If I go to my routes, there's no VRF that I can configure, so I'm fairly limited to what I can do as a service provider with IPv6 network on MikroTik at the moment, which is unfortunate, but it will improve with router version 7. So I hope that releases really soon, and I'm looking forward to actually testing it and playing around with more features added to the IPv6 functionality of MikroTik. Anyways, guys, I'd like to thank you for watching. I hope you've learned something. If you did, thumbs up the video, share it, comment, all that stuff. And if you're confused, feel free to comment as well. Ask me any question that you want regarding IPv6, and I'll see if I can figure it out with you or for you, and we can get to some point of understanding everything better together. So thanks again for watching. See you in the next video. Bye.